So here we have a generalized chain rule, which I can have multiple variables for my W, and then within that, each of those functions inside of that W, I can also have multiple variables for as well. So this can be M variables inside of W and N variables inside of X, each X sub I, I should say. So we're going to talk about this in the next page because we don't have enough room on this page to actually work this problem out down below. It says find dw ds if w equals some function of xyz and x equals some function of rst and y equals some function of rst and z equals some function of rst. So the xyz has three independent variables, and the w also has three independent variables. So that's a big mess if you think about it in that way. So let's just take a look at this breakdown. The lattice diagram really makes these simple to look at, I guess as simple as they can be. So let's just take this first, this w. Now the w breaks down into x, y, and z here. And then the x breaks down into r, s, and then y breaks down into r, s, and t. And then z breaks down into r, s, and t. Now for this one, we're just looking for dw ds. So I'm not going to get crazy and fill this whole lattice diagram in because it's not necessary. But I do need this dw dx and this dx ds. And I'm also going to need the dy, or I should say, dw dy, and this dy ds, and then dz dw dz and dz ds. And that's going to be our formula. So I'm just going to write that formula out now. So that formula is going to be dw ds equals dw dx dx ds plus dw dy times dy ds plus dw dz times dz ds. So there's our formula. And I'm going to get rid of all this lattice diagram stuff since we have our formula now because we're going to need probably all of this space. So first off, I'm going to find all the dwx, dwy, dwz. It'll just be easier for me to do it that way because then I'll have all my information quicker. So dw dx, that's going to be 4. dw dy, that's going to equal 2y, and dw dz, that's going to equal 3z squared. So there's our dw dx, dw dy, dw dz. Now let's find dx ds. Now dx ds, that's this function now. Now it's with respect to x. And e to the x is just e to the x times whatever's inside of it, and that's the chain rule. So that's going to be 2rs. So 2rs e to the rs squared. So that's the dx ds. Now the dy ds is going to be a little more weird because the derivative of ln is 1 over whatever I have in the ln. So it's 1 over r plus s over t. And then you have to understand that when I look inside of here, this is really r over t plus s over t. And to take it a step further, this is really r over t plus 1 over t times s. So this piece is really this here. 1 over t is my constant of my s. So when I take that derivative, with respect to s, that chain rule is just going to be 1 over t. And those t's will cancel. Very strange. So I end up with a 1 over r plus s. Hopefully you're okay with that. Not, get a hold of me. All right, now we're going to do the dz ds. So the dz ds is just going to be the derivative of the s there, but that equals, and I'm just going to write this another way. I want you to see this. RT squared times s. And if this is a power of 1 there, I bring that down, makes it 0, so that RT squared is just my constant, and that's what I end up with because the s was to the first power. So there's all of our partial derivatives that we're going to need for this dw ds. So now let's plug them all in. Okay, so first we need a dw dx. That's 4. So 4 times, now dx ds. Dx ds is here. So that's going to be 2rs e to the rs squared. So there's the first one. Actually, we might need a little bit more room here. I might drop it down a little bit. Actually, I'm going to. Because I'm going to run into this piece here. All right, so anyway, so now let's do the next piece. That's just the first one. So plus dw dy. So dw dy, that's going to be 2y. And dy ds, and that's here. That's going to be 1 over r plus s plus dw dz, that's here, 3z squared, times, and then we got dz ds, and that's here, that's rt squared. Now what I'm going to do is I'm just going to plug in for x, y, and z the functions of rs and t. And that just makes this go a little bit faster for me. So this is, I'll write 8 here. And then rs e to the rs squared plus 2. And my y is going to be ln of r plus s over t times 1 over r plus s, and that's what we have here. And then that's plus, and that's going to be a 3, and in place of z, I'm going to put rst squared times rt squared, because I'm plugging in for z here. And I got a little 2 above it, so I got to have that squared there. That's where that comes from, just in case you lost track of that. A lot of stuff going on here. So 8rs e to the rs squared plus, now for the middle term, there's not much I can do here. It's just going to look the way it looks. That's about the best I can do with it for the middle term. And then for the last one here, this is going to be plus. Now keep in mind here, I have a squared out here, so everything in there has to be squared. So that's going to be an r squared I'm dealing with times an r, so it's 3r cubed. And then I have this s that's going to be squared, and that's the only one, so s squared. And then my t squared is going to be squared, so it's t to the 4th, so t to the 6th. So there's our actual answer for this one here. This is our dw ds. And that's going to be, oops, let me try to get a better line here. It's going to be tough to circle it well. There, that's not too bad. So that's our answer for this one here.